Okay, this is lesson 4. We're moving on with segments. Now we're going to talk about how do we measure segments. If you remember, the definition of geometry was studying the properties, relationships, and measurement of things. And so we talked a little bit about the relationships yesterday between segments and lines and rays. The properties of them, they have to have endpoints or they don't have endpoints. They use a single bar or a double arrow. All these things. Today we're going to talk about measuring. So when we measure a segment, we can measure it based on the distance between. So let's say we add a point here and a point here, and we call this A, and this is B. We can find the length of that segment by counting its units, whether units are on a grid, a graph, whether they're on a ruler. The measuring of a segment really is just how long is it. So we'd count, I like to do the little bubbles. 1, 2, 3, oops. All right, let's get this right. I gotta make it all the way to 5. 3, 4, 5, 6. So this is 6 units long. So AB would equal 6 units. Simple enough. Sometimes we come to this situation of absolute values, and I don't remember if you remember them or not. Absolute values, so let's say we had a line. Ooh, why couldn't draw lines like that in the last unit? All right, let's say this was 0, -1, -2, -3. This is -5. This is 2. Okay, so let's say we have this segment here, AB. We can use an absolute value here if we don't want to actually count with the little hills or bubbles, whatever you call them. And here's how you do that. You have to take the absolute value of their differences. Okay, difference means subtraction. So remember, absolute value looks like this, and we'd have -5 minus 2. Now, if we do our little math, remember you have to fix this one to plus a negative. So -5 plus -2 is -8. Okay, but absolute value means we're going to drop that negative, which is going to leave us with just a +8. Now, let's go check our math and make sure that that's true. 1, 2, 3, 4, 5, 6, 7, 8. AB equals 8 units. Okay, so you can do it by counting, or if it's a number line, you can use the absolute value. Remember, if it's negative on the inside of the absolute value, after you do the math, it will become positive on the outside. We have these things called congruent segments. Congruent is maybe one of the most important words you will ever learn in geometry, and the symbol looks like this. It's an equal sign with a curly thing on top. Congruent things are things that are exactly the same. They have the same measure. They're the same length, or two angles that are congruent. They have the same degree measure, etc., etc. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. 8. So this is 8 units. I'm hoping this is also 8 units. 2, 3, 4, 5, 6, 7, 8. All right, so we could say that AB, the segment, is congruent to CD, the segment. Okay. This congruent symbol you will use in every unit somewhere, I'm sure, from now until the end of geometry. Double arrow, double is an equal sign with a curly Q. That means congruent. Memorize it. Super, super important. The next thing is our segment addition postulate. The segment addition postulate, you're probably going to say, well, duh. Who wouldn't already know that? The segment addition postulate says that one part of segment plus the other part of the segment will give you the length of the entire segment. Well, I would hope so. So if we look here at this segment, it's 1, 2, 3, 4, 5, 6, 7. This is 7 units from A to B. And from B to C, if you count 8, 9, 10, 11, 13. All right. The segment addition says, without counting the whole way, you should be able to know that this whole thing is 20 units. Because if from here to here is 7, and from here to here is 13, 7 plus 13 will equal 20. Okay, so this is where the algebra comes in to look at. This is the fun stuff. We're actually starting to do some math. This first one says that if dt equals 60, well, dt is this guy. So this whole length is 60. And ds is 2x minus 8, and st is 3x minus 12, we need to find x. Well, based on the segment addition postulate, I should be able to add ds plus st to give me the whole thing. Well, what does that look like? Well, ds is, let me see if I can do this. Let's see, 2x minus 8 plus the next section, which is 3x minus 12, would give us the entire thing, which is 60. Okay, so segment addition, we're always going to add a piece to another piece. Well, then we combine like terms, so I'm going to take the 3x and the 2x, and that makes 5x. And the negative 8 and the negative 12 makes negative 20. Those equal 60. I'm going to add 20 to both sides. It's going to leave me with 5x equals 80. I'm going to divide by 5 so that x equals 16. Alright, I've solved for x. I want to go double check and make sure that my work makes sense. So I'm going to come back over here and I'm going to find what ds. I'm going to take 2 times 16 minus 8. I'm going to plug that in. 2 times 16 minus 8. And if you do that, you end up getting 24. So this length is 24 here. I'm going to do the same thing over here. 3 times 16 minus 12. And if you calculate that, you're going to get 42. So I check, is 24 plus 42 60? No. So what do I do? Okay, well, I need to go and double check my work. So 2 times 16 minus 8, I double check, it is still 24. Well, so then I look and I say 3 times 16 minus 12 is 36. And I go, oh, well, I got 42 last time. How did I do that? When I look at it, what ended up happening was I accidentally added this 12 instead of subtracting it. So now I know that this should be 36. Now, is 24 plus 36 60? Yes. So now I know that I have done my work correctly. This is a super important step to make sure that we double check that we've done everything correctly. It's really, really easy, even for a math teacher, to add something when you should have subtracted it, or to get some things mixed up. So make sure we go through this checking process that we know we've done our work correctly. That's the segment addition postulate. The next major thing in this section is about midpoints. A midpoint is a point that is in the exact middle, hence the name midpoint. Okay, it divides the segment into two congruent segments. Here's that word, congruent again. Congruent means they have the same length or the same measure. So if we have this segment AB and we are told that C is the midpoint, you have to be told, okay, we're not allowed to assume, told that C is the midpoint. Now we know that AC has to be the same length as BD. Now this is going to drive you crazy sometimes because in geometry we have a number one rule. Number one rule is geometry is you cannot trust the picture entirely. Okay? There are certain things that you are not allowed to assume. You cannot assume that this is the midpoint. You cannot assume that something is a right angle unless you are told that. We'll find some more of those later. So if you're told it's a midpoint, or if you actually have values here, like we do, we can count 1, 2, 3, 4, 5, 6, 7, 8, okay, and then this is 8 too, then we know it's a midpoint. But down here in this one, we have to be told it's a midpoint in order to solve this math problem. So midpoint, again, divides a segment into two congruent segments. All right, let's do this last example. This is an example of a midpoint. The midpoint here is F. So if this is the middle, then this part should be the same as this part. So in this situation, they should be equal. The whole philosophy is that we have two congruent or two equal parts. So we should be able to say 2x plus 1 equals 3x minus 4. Okay, so notice it's different than what we did in the segment addition. In segment addition, we did that. We added our segment pieces. But in a midpoint, we're going to set them equal. So I'm going to minus 2x to this side. And then I'm going to add 4 to the other side. Okay, so these two are going to cancel. And then I'm going to add 4. I'll do it in another color. Add 4 and add 4 here. Okay, and these two are going to cross out. So when we look at what we finally have, we have 1 plus 4 is 5. And 3x minus 2x is 1x. So x equals 5. So I need to go double check my work. So 2 times 5 is 10. 10 plus 1 is 11. 3 times 5 is 15. 15 minus 4 is 11. Are these two equal to each other? Yes. So that means this was a midpoint and we did our math correctly. Okay, so remember, we can measure by counting spaces if we're on a number line. In segment addition, we add two segments together to equal the total. And then in a midpoint, you set the two pieces equal to each other and you solve that way.